Welcome for the next lecture on the fluid mechanics. Today we will see the types of fluid. In the types of fluid, we will see how the fluid is classified. Initially, fluid is classified into real and ideal fluid. This is first, this is second. Further, real fluids are classified into Newtonian fluid and non-Newtonian fluid. Further, non-Newtonian fluid is classified into ideal plastic, real plastic, shear thickening and shear thinning. One by one we will see the classification. See, ideal fluid, most important, is incompressible and doesn't have any viscosity. If you see the fluid, every fluid has viscosity. So such ideal fluid doesn't exist and it is called as imaginary fluid. And day-to-day life, whatever fluid we possess has viscosity and it is a real fluid. All fluids existing are real fluid. Further, as we saw before, real fluid is classified into two groups, Newtonian fluid and non-Newtonian fluid. Newtonian fluid is the common fluid, water, air are Newtonian fluid, and those fluids are obeying the Newton's law of viscosity, means shear stress is directly proportional to rate of shear strain, that is Newtonian fluid. And if the shear stress is not directly proportional to rate of shear strain, it is called as non-Newtonian fluid. Then again, Newtonian fluid has no any further classification for sake of convenience for your syllabus. Shear thinning is the example for non-Newtonian fluid, which is also called as pseudoplastic or thixotropic. Harder the fluid is sheared, the less viscous it will become. Latex paint is the best example, where we can see the drop of brush. If we take it on brush, it will not drop down. Means it looks like a solid at that time, but while painting it flows smoothly like a fluid over the wall. Means harder it is sheared, less viscous it becomes. Exact opposite to that, there is a shear thickening. The viscosity increases with increase in shear strength. Harder the fluid is sheared, more viscous it becomes. Dilatants, it is also called as dilatants. Water and starch mixture is the best example. There is another one which is called as ideal plastic, the fluid that behaves as a solid until a minimum yield state stress. It exceeds, if it is exceeded, it behaves like a plastic. So relation between the rate of the deformation as ideal fluid. So there is one video in which we can see the example. So that man can run over the mixture of water and corn. Initially it is looking like a fluid. When it is having shear stress over it, it behaves like a solid. See. See, when it is sheared, it behaves like a solid. Then we will move for the properties of fluid. One by one we will see the properties. Initially, what is meant by property that we will see? It is intensive property or extensive property. Extensive properties per unit mass are called as specific properties. Then we can see the properties. First is density, which is denoted by rho, specific weight or specific density, specific volume, specific gravity, or we call it as a relative density, and viscosity. One by one we will see. Density is defined as mass per unit volume, that is rho is equal to mass upon volume. Then specific volume is defined as reciprocal of density, that is 1 by rho, and that is volume divided by mass. The specific weight is defined as the weight per unit volume, that is W is equal to rho into G. Specific gravity or relative density is defined as it is a ratio of density of the substance to the density of some standard substance at a specific temperature. The next one is viscosity. It is an important property. Viscosity is the property that represents the internal resistance of fluid in the motion. It is a property of fluid which offers the resistance to the movement of the one layer of the fluid over another adjacent layer of the fluid. You know that fluid is flowing in the form of layers. One layer is offering resistance. So this viscosity occurs due to that. Here in the example, you can see how this property is exhibited. One jar contains water, another jar contains gel-like structure. You can see the difference in the viscosity of both. The next important property comes in the surface tension. Surface tension. Two examples are here. One is some insect on the water and some leaves are on the water. Those examples exhibits the surface tension. Many of you have seen that needle is supported on the water surface without being wetted. This is due to surface tension of the water. Then surface tension is defined as the work Newton meter per meter square or Newton meter required to create unit surface of the liquid. The work is actually required for pulling up the molecules with lower energy from the surface. Another definition is surface force required to keep unit length of the surface film in equilibrium. It is important. The formation of the bubble, droplets and free jets are due to the surface tension of the liquid. Then due to surface tension, one phenomenon occurs is called as capillary action. When we insert a small diameter pipe tube in the water or in the mercury, you can see the capillary effect. In case of water, the water level increases. In case of mercury, the mercury level decreases due to this capillary action. Today we will see that these things. Next lecture we will move for the next points. Thank you.